2 miles from Prescot is the Highton Quarry Factory of the BI, where enamelled wire is made. The wire has first to be wound onto special reels in preparation for the enamelling machines. The enamel is applied by passing the wire through a bath and then an oven of closely regulated temperature, which bakes the enamel to a tough and elastic consistency. The process of immersing and baking the wire is repeated several times until a coating of enamel of adequate thickness is built up for the purpose to which the wire will be put. The enamel used has extraordinary qualities as an insulator, and in nearly all cases is the only insulation with which the wire is provided. It will stand, without deterioration, temperatures which would destroy insulation of a fibrous character. Enamelled wires are used almost exclusively where the space factor is of importance, as in telephone receivers, wireless apparatus. We are now in the Helsby Works near Warrington, where rubber insulating and covering is done. The conductors of rubber insulated wires and cables are of tinned copper and may be single wires, strands or bunches of wires. The machines here are making strands of various numbers. With stranding, as you have seen, the reels holding the single wires are rotated in the machine. When wires are bunched, however, the spools of fine wire are fixed on a frame, and the reel on which the completed bunch is wound is rotated at very high speed. Now let us turn to the preparation of the rubber used for insulating. It is of vital importance that the raw crepe rubber shall be absolutely clean, and great precautions are taken to ensure this. The raw rubber with various powders is mixed on mills with steam-heated rollers. After the mixing, the rubber is calendared into thin sheets, which are wound up between calico to prevent the layers sticking together whilst yet warm. Next, these sheets of rubber are cut into strips, ready for the covering machines. This is the rubber covering shop, where wires and cables of all sorts and sizes are covered with rubber. The method of covering is what is known as longitudinal. In this machine, 24 tinned copper wires or small strands are led from their reels into a flat band which passes into the machine with a strip of rubber compound above and below it and is fed through accurate grooved rolls which, acting by crushing and cutting the rubber, surround each conductor with a layer of the compound with a perfect seam on each side. According to the thicknesses of rubber required, this process can be repeated. As a general rule, 3 such layers are applied. This process is applicable to single wires and conductors which are not large in diameter. When larger strands are to be covered, the rubber compound in strips of the required thickness and width is lapped on the conductor. In this big machine, 5 such layers are being applied at the same time. These larger cables are used for main cables for motors and transformers and for service cables. Another type of cable, used for instance for house wiring, is covered with a tough rubber sheath. This tough rubber sheath, without seam, is extruded by pressure over the cable. The girls are laying rubber cable in the tray, ready for vulcanizing. After vulcanization, tough rubber sheath cables have the maker's name and grade of cable printed on the surface. All rubber insulated cables are tested in water in which they have been immersed for 24 hours. They are first subjected to a straining voltage, several times that at which they are intended to work. Some cables, as you have seen, are tough rubber sheathed, while others are braided and compounded. Another type of finish consists of lead or alloy sheathing. The molten metal is charged to a lead press, which extrudes the lead or alloy under great pressure round the cable in the form of a seamless tube. Motor car cables are provided with several different finishes, and one of the most common is an armoring of a spiral of bright aluminium wire. Most of the conductors you have seen are made of copper. In order to provide the exceptional flexibility required by telephone instrument cords, the conductors you see here are made of tinsel. Other machines are covering very fine wires with a layer of the purest quality silk. In some cases, wires so small as 1/1000th of an inch in diameter are covered. Before cables are dispatched from the works, they are wound onto suitable drums. Here is the alloy sheathed house wire being automatically measured and cut into 100-yard lengths. Such a large and varied output of cables and wires receives ample evidence in the finished material stores, where large stocks are kept ready for immediate dispatch to any part of this country or abroad. From the stores, the goods are conveyed to the adjoining railway station by our own narrow gauge railway.